Let's solve this question here. Block X and Y are connected by a friction line passing over an essentially frictionless pulley. So here's a diagram. So here's block X, block Y, and they're connected by a friction line here, passing over a frictionless pulley. And block X is moving at an incline. Now, let's look at what it's asking here. Part A. Show that block X slides up the incline with a positive acceleration. Determine the magnitude of that acceleration. Friction is negligible. Okay, when they say friction is negligible, they talk about the friction between the block X and the surface here on the incline. So there's no friction here. Also, the question has chosen the axis for you. So this way, right, to the left side is the positive x-axis. And this way, the downside is the positive y-axis. So it's like the opposite of the Cartesian plan, okay? So we will follow this direction here. And if we calculate the acceleration, right, using this instruction, right, having this side as the positive x-axis and having the downside as the positive y-axis, and the value of the acceleration, if it's positive, then it's experiencing a positive acceleration, right, going up the incline for block X. Okay, so let's see how this is, okay? So to save time, I have already started the diagram for block X here, right? So now let's look at all the forces acting on block X. Okay, so first of all, of course, right, there will be a tension force pulling this way. So this is the tension force. Now remember, this way is the positive x direction here in the question, okay? And of course, there's always force of gravity pulling downward. And it's pulling this way, right? It's pulling down the ramp. So, but this is the x direction, right? So I would say this is Fg sub x, right? The force of gravity in the x direction. And of course, there's always force of gravity pulling downward like this, right? So this is the Fg, right? Force of gravity. Okay, so now what else? Since the block X is on top of the incline or the ramp, there's a normal force exerted on the block X by the incline. So here, like this. Call this Fn. Okay, now here, what forces do we care about in this question? We really only care about the tension force and the force of gravity pulling in the x direction, right? Because the block is moving up this way, right? In the positive x direction, according to the question. And the force of gravity is pulling it down this way, right? That's all we care, these two forces. We don't need to worry about the normal force or the force of gravity in this way or anything like that. Because here, right? Looking at the diagram here, right? We only care about the block moving this way or it may pull it back this way. That's all we care. Okay, so only these two forces here, the forces in the horizontal axis that we care about. Okay, now, how do we calculate the force of gravity in the x direction here? Now, we have to break down the component. So here, this is the force of gravity, right? In a vertical line. And of course, here, the force of gravity in this component will be the y component. And of course, right, that will be the x component. So this one here is Fg sub y, and this one here is Fg sub x. Now, this is the force of gravity in the x direction, which is parallel to this component here, which is also the force of gravity in the x direction, right? And of course, the normal force and the force of gravity in the y direction will cancel out. Just in case that, right, the magnitude of this force is not the same as this force, I'm going to draw it again, right? It should have the same magnitude, right? Because it cancels out. Okay, now, after we break it down into component, right? Here's a right triangle here. Now we know that this is a right angle, right? So what's the angle here? We need to know this angle in order to calculate fg sub x or fg sub y, right? So what's the angle here? Okay, so we have to look at this triangle here now. We know that over here, this is 90-degree angle, right? If this is theta, let's call this alpha. What does that mean? All angle in a triangle add up to 180 degrees, right? So that means here, theta plus alpha plus 90 degrees equal to 180 degrees. This is 90 degrees. Now, over here, right? We know this is alpha. What is this angle here? Now we know that this is the incline, right? The surface of the incline. And this force of gravity, is perpendicular to the incline. So this is 90 degrees. Now we know that this angle here is 180 degrees. So if I take 180 degrees minus 90 degrees minus alpha, which is this, right? So 180 degrees minus 90 degrees minus alpha is this angle here. But what is this angle? Look at this equation here. If I take 180 degrees minus 90 minus alpha, we get theta, right? So this is theta. So this angle here is theta. So this angle is the same as this angle here. Okay, now we know how to calculate the force of gravity in the x direction and also the force of gravity in the y direction now. So let's write that out. Here. Let's talk about force of gravity in the x direction. Using trigonometry, right? It would have been Fg sine theta, right? So Fg sub x is equal to Fg sine theta. And Fg is equal to mg. So Fg sub x is equal to mg sine theta. How about Fg sub y? Here, this one, right? So using trigonometry should be Fg cosine theta, right? So this is Fg cosine theta. Again, Fg is mg, mass times gravity, cosine theta. Now, like I said at the beginning of the questions, we don't need to worry about the force of gravity in the y direction. We just have to worry about the force of gravity in the x direction, which is this one, right? Now, let's write an equation for all the forces acting in the horizontal direction of block X, which is the X direction of block X. Now remember, we're choosing this one to be the positive X direction, okay? So again, this side here is positive X direction, okay? So our equation should be like this. Tension force minus force of gravity in the X direction equals to, right, mass times acceleration, right? Because it's moving upward this way. So we will write this. Tension force minus Fg sub x is equal to mass of the x block times acceleration in the x direction. here, right? Now, we know that the formula for fg sub x is mg sine theta, so minus mg sine theta. Okay, now let's be more specific. So here, because we're talking about x block, so the m here is m sub x. Okay, here, let me write it again here. So this one would be m sub x g sine theta is equal to m sub x times acceleration in the x direction. Okay, now this is the equation of the net force in the x direction of block x, acting on block x. Now, let's look at block y. Okay, now block y. What are the forces acting on block y? Look at this diagram here. It's the tension force and the force of gravity, right? So here, there are only two forces. So one is the tension force, and then force of gravity. Now, remember, in the original question, they choose the downward direction to be the positive y direction. So here, our equation should have been like this. Force of gravity minus Ft equals to mass times acceleration, right? So Fg minus tension force is equal to mass, but this is the mass of block y, right? Times acceleration in the y direction. And force of gravity is mg, right? So again, this is m sub y times g minus tension force is equal to m sub y times a sub y. Okay, now we have the equation for block y as well. Now notice that this is the acceleration in the y direction, and that's the acceleration in the x direction. We're looking at the diagram here, right? Block y will move down at the acceleration the same as the acceleration of block x moving up, right? That's a frictionless pulley here. So whatever acceleration y is experiencing is the same acceleration that x is experiencing. So the magnitude of the acceleration will be the same for both blocks, although the directions are not the same. So for these two equations here, right? Acceleration, I can take away the subscript. So for block x, I can write that tension force minus m sub x g sine theta is equal to m sub x times acceleration. Okay, now for block y, here, I can take away the subscript y here. So that would be m sub y times g minus force of tension equals to m sub y times acceleration. Okay, so acceleration here will be the same. Now, what else do we know? Look at this diagram here, right? Since the pulley is frictionless, given in the question here, the tension force on this fishing line will be the same here or here. So the tension here is the same as the tension here, right? Given that this is a frictionless pulley. So that means we can say that f sub t here is the same as f sub t here. Okay? Then, now we have system of equation. Let's solve for acceleration here. Okay, so here, let's isolate this one here. So this one we can say that the tension force is equal to, you add mg sine theta on both sides, we have m sub xg sine theta is equal to m sub x acceleration, right? So now you can put this into here. So m sub y g minus m sub xg sine theta. Okay, so this is a plus side, right? So this is a plus side. Okay, so plus m sub x a equals to here m sub y times acceleration. So let's take away the bracket, right? So we have m sub y g minus m sub x g sine theta minus m sub x a equals to m sub y a. Now add m sub x a to both sides, right? So that we can move all the acceleration variable to one side. So we have m sub y g minus m sub x g sine theta is equal to m sub x a plus m sub y a. Isolate a. So we have this m sub y g minus m sub x g sine theta is equal to m sub x plus m sub y times a. Divide both sides by m sub x plus y. So we have a equals to m sub y g minus m sub x g sine theta all over here m sub x plus m sub y. Okay, now let's put in the numbers, right? Okay, so mass of y would be here 3.22 kg. 3.22 times the gravity is 9.8 minus mass of x, which is 5.12 kg. 5.12 times the gravity is 9.8 sine theta. And we know that theta here, right? Theta here is theta here, right? 35.7 degrees. Sine 35.7 degrees. All divided by now mass of x, which is this one here. 5.12 plus mass of y, which is this one here. 3.22. And that will give you the value of 0.273 meters per second square, because it's acceleration, right? Okay, so block X is experiencing 0.273 meters per second square acceleration, right? Upward in the incline, and we know that the acceleration is a positive value. So this also answer this part of the question here, right? It's sliding up the incline with a positive acceleration, right? Okay, now that's part A. Let's look at part B. Determine the magnitude of the tension in the fishing line. Here, part B. Part B is easy. Now, we want to calculate F sub t here. That's part B. Since you have acceleration, right? You can put it into either one of this formula and just calculate F sub t. But let's put it into here, right? This one here. Okay, here. M sub y g minus f sub t equals to m sub y a, right? Acceleration. Now, just isolate f sub t. So we have f sub t is equal to m sub y g minus m sub y a. So f sub t is equal to mass of block y, which is, yeah, 3.22. 3.22 times 9.8 gravity minus 3.22 times acceleration that we calculated, 0.273. Now, f sub t is equal to approximately equal to 30.7 Newton. Okay, so now this is the answer to part B. This solved the question here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.